Hello everyone, my name is Sampath. Our team worked on the project titled Performance Evaluation of Leech and Pegasus Protocols in Wireless Sensor Networks. I worked as a performance analyst for this project. To begin, wireless sensor networks consist of small sensor nodes that monitor the environment. One of the biggest challenges with these networks is energy limitations. Sensor nodes typically run on small batteries, and once they run out of the power, the entire network's performance starts to degrade. Because of this, designing routing protocols that conserve energy and increase network lifetime becomes extremely important. In our project, we focused on evaluating two well-known hierarchical routing protocols, Leech and Pegasus. Our goal was to analyze how two protocols differ in terms of efficiency, latency, and energy consumption. For our simulation environment, we used OMNet 6.3.0 along with INNet 4.5 framework. The topology consisted of 18 sensor nodes organized in clusters and a single base station. Thank you.
Hi, I'm Abhinay. I'm the network topology designer. So I've worked on most of the NAD modules for this project. And coming to the leech protocol, this is our first protocol. We have implemented the leech, which stands for the low energy adaptive clustering hierarchy. This is a classic cluster based protocol based to fix the problem of every node trying to talk to the base station at once. The core mechanism for the leech relies on organizing the network into the clusters, sending off raw data directly to the distinct base station, and the sensor node sends the data to the local leader known as the cluster head. This cluster head aggregates the data, compressing the multiple signals into one, and performs high power transmission to the base station. To prevent these leaders from draining their batteries instantly, this protocol uses the randomized rotation system. In every round, different nodes elect themselves as a leader based on the probability of threshold, ensuring the heavy workload and shared over time. In our simulation, we have observed the leech has a significant advantage regarding the latency, and it has some disadvantage where the energy drain is quite uneven. Thank you.
Hello, I'm Sharan. I'm the systems architect of the project. I have installed and configured OMNet++, along with installing various other required frameworks like iNet. I have also assisted in setting up project simulation. Today I'll be talking about Pegasus protocol. Pegasus stands for Power Efficient Gathering in Sensor Information Systems. It is an improved data gathering protocol for wireless sensor networks. The main goal of Pegasus is to reduce energy consumption and extend network's lifetime. Instead of forming clusters like Leech, Pegasus creates a single chain of nodes, where each node communicates only with its closest neighbor. This reduces long distance transmission and saves a significant amount of energy. During data collection, each node receives data from its neighbors. Aggregates Each node aggregates this information along with its own reading and forwards it along the chain. Once the leader receives this, only the leader transmits the data to the base station. Rotating the leader role prevents any one node from dying early. Pegasus is energy efficient and extends network lifetime, but it can also introduce delays since the data must travel through many nodes. Overall, Pegasus is a simple and efficient protocol that minimizes power usage by using neighbor to neighbor communication and a single leader transmission. Thank you.
My name is Rohan Mulkuntla. I'm lead developer and system integrator. I have wrote C++ code for Pegasus and Leech algorithms, handled routing layer and integrated NAD with CC. We have built this project using OMNet 3 Plus with a version iNet framework. This provides us the pre-built modules for batteries and radio. The basic structure is we have divided into three things: .nad, .cc, and .msg file. .nad files the base station release NAD basis NAD sensor app.nad. This is acts as a blueprint. This defines the body of the node, connecting batteries, accessing radio channels, etc. And .cc and .h is a brain which has C++ logic for energy, battery, and every Leech and Pegasus. And MSG, we created a custom package structure that allows our nodes to have check energy and the loop hopping count. So how to run the code? Go on to the OMNet INI file, click on Run as and click on Omelette Simulation. We do have different simulation. You can select P, Leech or Pegasus. For Leech, we have different energy from 14 joules to 26 joules and 14 joules to 26 joules in Pegasus with different types of repetition, 0 repetition, 1 repetition, and 2 repetitions. As for example, let me select the 18 repetition for the Leech with the energy of 18 starting energy with 1 repetition and click on OK. Once it's done, click on the simulation button. Initially, the energy will be assigned. Once you click, let me fast forward for you. And this is how the leech is going to work. If you want to run the Pegasus, let me close it for you. It will take so much time. So once again, right click, run as an omelette simulation. So you can select the Pegasus, click on OK. So once you select this, let me fast forward for you. So this is how the logic works. Let me close it for you. And this is our I have collected the details. I have selected 3 repetitions. I have selected we have run 3 simulations of leads, 3 simulation of Pegasus. These are some of our results with the packet delivery and end-to-end delay. And thank you.
Here, we compare Pegasus and Leech based on 3 performance metrics. First, the residual energy and end-to-end delay and the throughput. First, looking at residual energy, we can see that Pegasus has much more flatter decline, meaning nodes survive longer. This is because Pegasus forms a chain structure which distributes energy consumption more evenly. In contrast, Leech shows a steep drop because cluster heads deplete energy very quickly. Next, for end-to-end delay, Leech performs better, showing a delay of around 1 second. Pegasus, however, has a much higher delay, about 2.7 seconds, because data travels through multiple nodes before reaching the base station. Finally, in terms of throughput, Pegasus achieves higher packet delivery. It's a chain-based communication which reduces the collisions and also makes retransmissions, which will lead to better overall delivery rates. In conclusion, Pegasus is a much better choice when network lifetime is the priority, while Leech is more suitable for applications needing faster data delivery.